Well, hello everyone. This is the first in a series of short lectures that I'm putting together to go over some concepts, some concepts that I think benefit from a visual perspective. But I do want to tell you though that these short lectures will not cover everything that you need to know for your exams and quizzes. For that, you're going to have to go to uh, the learning objectives, the key terms, and look at the overview and the review of every chapter and the resources provided by your text. Okay, so to start chapter one, let's start talking about latitude, longitude. That's the coordinate system that we use to locate points or places on Earth. Notice there's two very important lines. There's the equator, which runs east to west, and that's what we use as the reference point to measure locations that are either north or south of the equator. So the equator divides the Earth into a northern and southern hemisphere. So notice that it runs through, the Amazon rainforest. There is rainforest in Central Africa, but not everywhere that where you find equator is rainforest. Look at East Africa. That's a drier place. The other important line is the prime meridian, and this is a line that was arbitrarily chosen uh, as the point of origin for measuring longitude. So basically, this line divides the Earth into an eastern half or hemisphere and a western half. Okay, and as you probably saw in the Google Earth uh, exercise, we use positive numbers for the eastern half, negative numbers for the western half, and positive numbers for the northern hemisphere and negative numbers for the southern hemisphere. Another concept is that of projections. The Earth is a sphere, well, not quite, but almost a sphere. And when we try to portray the Earth on a flat map, distortions are bound to happen. So here in this projection, we see that the main type of distortion that we have is that areas get progressively larger as you move towards the edges to the northern edge or the southern edge of the map. And for example, if you look at Greenland, Greenland here looks about the same size or actually larger than South America, when in reality it's only about 1/6 the size of South America. Here's another projection where we can see Greenland smaller now and smaller than South America considerably. And you may wonder, well, why would anyone use this projection? Well, this projection shows the correct shape. So if you look at Greenland, that's the actual shape of Greenland. Here, Greenland is all squashed, as are all the other locations that are at a very high latitude. Okay, so you can never, as the song says, you can't always get what you want. So, but if you try sometime, you get what you need. Well, that's the same thing with projections. We have to compromise. So in some cases, you're interested in having the correct shape. In other cases, you may be interested in having more correct sizes. Here is the concept of scale. Scale, we geographers refer to a map when we say that it has a small scale. What that means is that it's zoomed out. So in this case, this is a small scale map. What we gain by having a small scale map is that we cover a large area. What we lose is detail, right? So if you look at this zoomed in section here, this is a large scale map. So we gain detail, names of the streets, and all that, but of course we can only see a small portion of the map. So again, we can't always get what we want, but we have to make decisions on what is it that's most important. Here the scale bar shows you the distances, okay, on the map. So the next concept is one of chloropeth, sorry, maps. These are maps that show that use some type of either shading or color coding to show a feature. So here we're looking at a map of density, population density in South India, so I mean South Asia, so showing India and Pakistan and Bangladesh and a couple of other countries here. So you can see based on the shading, the darker shading means, of course, more people. Here's another map in which we don't have a gradual, change of colors, shading as we had in the previous map, but we do have very distinct colors that represent different climate type. Another name for this type of map is thematic maps. Moving on to remote sensing and GIS. So you'll experience both of these in this class. Remote sensing are, of course, images acquired from above, photographs and other images acquired from above. They can be acquired by a satellite, by an airplane, nowadays by a drone. So anything that's up there and can take a picture from above is doing remote sensing. GIS, Geographic Information Systems, refers to, well, it's both computer mapping, but it goes beyond that. It's computer analysis. So using spatial data, so information about a place that can be mapped out to conduct analysis. So here you're looking at, different layers. A remote sense image can be part of a GIS, but wetlands, land covers, soils, you put them all together and do some type of analysis. And you're going to be doing that, or you actually have started doing that this week when you're creating your own map in a web page that allows you to add your own layers to a map and display them. So world regional geography, what are the regions? So here are the regions that we'll be discussing because we won't have time to do every single one of the regions. There's a couple of them that we're going to have to skip, but we'll do most of them. Okay, so this is a good map to refer back to if you need it, if you need to remember where the different regions are. Here again, a thematic map or a choropleth map that shows population density of the world. Well, let me go back to that one a little bit. So basically, what we're trying to see, where do we find the biggest population centers? And as you can see, and you'll find this to be true in most of the maps that we do, is that population in this case, or any other feature that is mapped, you'll find that it's usually not evenly distributed throughout the earth. Some places have big concentrations, other places don't have very much. So we tend to see that features get clustered or not evenly distributed. So here we see places such as Bangladesh here, very high concentration population concentration, and even all the South Asian, all the Indian subcontinent, Eastern China, especially northeastern China, very high concentrations. Europe, right, northwestern Europe, the UK, very high concentrations of people. But other places are pretty empty, right? We hear, this is where Himalayan mountains are, for instance. The Saharan desert, except look at this little dark stream. What do you think that is? Well, that's the Nile River, where most of the population of Egypt live, and outside of that, it's pretty empty. So it's good to remember if you look at so here if we look at Africa, look, Nigeria seems to have the high concentration of population. But what I was saying is that it's good to remember that population, as many other features you're going to see in maps, are not evenly distributed throughout the Earth. Population growth and change. So again, this is just a table showing you the different countries of the world and their population. There's a video that you're going to be watching on population pyramids. If you haven't seen it already, I think it's very good and it explains to you what it means. And here we have two different ones. One that shows rapid growth. A lot of developing countries have this type of population where most of the population, or at least half of the population, is young, under 20 years old. And other countries like the United States here have a more even distribution of ages and a slow growth. And some countries like Japan or Germany or Russia actually have a negative growth, meaning that their population is actually shrinking every year. Here's a map of languages. And an interesting thing to note is that these are language families, which are very large groupings. So English, for instance, is part of the Indo-European language family, which includes, not just about every language spoken in Europe and the Americas, but also includes languages spoken in India, Pakistan, Afghanistan, and Iran. So it's a very large family of languages. So once, when you do that, you see that there's not really very many large language families, even though there are thousands of individual languages in the world. Or religions, again, just look at the maps, look at the distribution. Interesting thing to note are the Native American, in this case, or indigenous languages that are spoken throughout the world. Here's an interesting map of a population without a country, even though it's an individual ethnic group. Here it's the Kurds who live in this area that is divided between 3 or 4 different countries, actually. The colonial imprint, meaning that all these countries, and actually, all of Latin America, were colonial possessions. Latin America is not shown here because it is from 1914, but that colonial history really has had a big impact on the development and culture and other aspects of all these countries, mostly, Africa, Asia, Southeast Asia, and Latin America. And some of that imprint we see here, we see that the least developed countries are found in Africa, some in Latin America, and some in Asia. But the core periphery model says that the developed nations, what we call developed nations, are not completely lacking in responsibility for the lack of development in these countries, because they have exploited resources from their colonies and in a way arrested their development, stopped or slowed down the development of these countries. Here we see the Human Development Index that includes not only how much money or how much development each country has, but how well does it take care of its population. So we see that countries like Chile and Argentina, which are not, highest developed countries, they still have a high Human Development Index.